So let's resume because we have lots of things to cover. So we are going to expose containers because it's nice to have something that pings the folks at Google, but it doesn't really help us with our microservices deployment. What we are going to do is create a service. And so that can be a little bit confusing at first, especially if you come from the Docker ecosystem where a service means a bunch of containers that expose a service. In Kube, a service is just the endpoint for that. In the initial proposal for services, they were called portals, which I find that easier to understand because a portal is like this thing that leads to the containers or the underlying backends or services. Because a service can send traffic to a bunch of pods, but it can also send traffic to an external server or whatever. So we have multiple types of services. We have cluster IP, which is the default type. So when you create a service of type cluster IP, then Kube will allocate an IP address for the service. And then this is the stable IP address for the service. It will remain for the whole lifetime of the service. So that's convenient because you can destroy everything, like the pods related to that service, and later you can create new stuff, but the IP will still be the same, so that IP is stable. Then you can also have a service of type node port. In that case, it will allocate not only a cluster, not only an IP address on the cluster, but the port number. And if you connect on any node on the cluster on that port, then that will route you to that service. So that's a way to expose services to the outside world, because you can say, hey, I'm gonna use port like 30,000, and then when you connect to port 30,000 on the cluster, on any node, your traffic gets routed to the right place. You have a couple of other service types like load balancer and external name. Load balancer this one is confusing at first when you come from a hardcore on-prem physical machines background, because when you create a service of type load balancer, what it will do is that it will in fact allocate a load balancer on your cloud provider infrastructure. So if you're on AWS, it will be an ELB. If you're on GCE or Azure, it will be the equivalent load balancers on these cloud providers, etc. You could also write your own service controller to interface with, for instance, F5 hardware load balancers. Some people, I think, have made load balancers to use HA proxy, etc. And in that case, the idea is that you will still use the Kube API the same way, like, hey, I want to create a service to expose those pods, but this time it will communicate with your hardware load balancer to set up everything. You can also have an external name. So in that case, no IP address will be allocated. It will just be a name mapping. All right. So we're going to see that in action. I'm going to create a bunch of Elasticsearch containers. So kubectl run. I'm going to call that ES, like Elasticsearch, or Elastic. Don't call it search for reasons, because search is also a TLD, a top-level domain, and that would cause extremely interesting problems down the road, because when you do ping search, you're like, it pings. So you would think, oh, I can ping my service. No, you're just pinging something else that is completely unrelated. So let's call it Elastic, because .elastic doesn't exist yet. So kubectl run elastic -- image equal Elasticsearch :2. :2 is important here because the default Elasticsearch image on the Docker Hub requires a config file. So if I just put Elasticsearch, then the container will start. You're like, I don't have a config file. I'm going to stop. And then Kube will try to restart it forever, and we will never get something that works. If we use Elasticsearch :2, it's an older version of the image. It doesn't need a config file. It will start right away, and that's good for the purpose of this tutorial. Okay, and then I will right away indicate I want 7 replicas. All right. I'm going to do like kubectl get pods -w. So I see that my Elastic containers are creating. And if I show a little bit of patience, then we'll go to the running state. Oh, I put 7 instead of, oh, what? Yeah.
We'll get to 7 if we
Yeah, absolutely. What did I say? Okay. And then I'm going to, yes?
Is the status image pulled back off and wrong state?
Oh, if it says like back off or something like that, that's bad news. If it does that, double check the image name that you've put. Like make sure there is no typo in the image name. Like it's really like Elasticsearch :2. This could be the common problem.
So we have it running, image pool backup, error image pool. They're all, I mean, it's one command, so one got.
Oh, for some of them, error image pool. Let's ignore that error for now. It's probably because, as it says, like okay, it couldn't pull.
Also got the same issue.
Yeah.
Here in running state now, after a couple of minutes.
Well, I can have a look at that pod to see what's going on. So I'm going to do kubectl describe pod elastic, etc., etc. And I see, okay, successfully assigned, failed to pull image Elasticsearch :2, RPC error, context cancelled. So something wrong happened while pulling the image, but I'm pretty sure that it will retry after a while, and eventually it will succeed. We had reports of problems on the CloudFront distribution points used by Docker Hub recently, so this might or might not be related. But in that case, it's fine to ignore that for now, because one of the replicas is dead, but we have more, so that's fine. Okay, so I have my Elasticsearch containers running, but I want to be able to connect to them. So I'm going to do kubectl expose deploy /elastic and --port equal 9200. So if we had a layer 3 network, the port number would not be necessary. I could just say, hey, expose this. It would give me an IP address, and I could connect to that IP address. But as I said earlier, in fact, under the hood, we have a layer 4 network. So when I create a service, I have to give a port number, and it will create IP table rules, etc. So I do that. Okay. And then I do kubectl get service, or SVC in short. So I still have like my Kubernetes endpoint, and now I have this Elastic service with a cluster IP that is like 1096, blah, 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 blah. Okay, I'm going to curl this IP address on port 9200. Why port 9200? Because that's the default port for the Elasticsearch HTTP API. Oh, I'm sorry, let me move that on top. So kubectl get service, and then I get this IP address here, and I curl on port 9200. And this is the default route for the Elasticsearch API. Why did I pick Elasticsearch? Because it generates a random name for each node. And so if I do multiple requests, I see that it's cycling over different backends. So it's kind of confirming that when I hit that IP address, I'm in fact connecting to a load balancer, and it's sending traffic to all the pods behind. Okay. That's a little, and this command, like this complicated command, is something if you want to extract that IP programmatically. I put that here for two reasons. The first one is that we have an automated testing system that we use to go over all the slides and make sure that all the commands work properly. So that lets us get the IP address programmatically. And I also know that many of you are going to use scripts, etc., to get like, okay, I just created a service, but what's the port number? So I wanted to give you a bunch of useful commands for that. Okay. So we found out how to expose a service. Great. Now how do we run the Docker Coins app on the Kube cluster? Here we are going to use the Docker motto. Maybe you've heard like the Docker slogan is like build, ship, and run any app anywhere. And at first it looked like, well, this is some marketing bullshit or something. But here we are going to see exactly what build, ship, and run corresponds to. We are going to build the images for the app. Then we are going to ship them to a registry. And then we are going to run deployments using these images. And then there will be a few extra steps about exposing the deployments so that the services can talk to each other, and exposing the web UI so we can see the blue graph. We are going to build everything on Node 1. And then we are going to run a local registry. And we are going to push the images to the local registry. Okay. We could use other registries as well, like we could use a Docker Hub, or we could use GCR or ECR or Quay, etc. But in that case, I'm going to use the self-hosted registry because it's faster, simpler, etc., etc. If you want to run your own Docker registry, it's pretty easy. You just need to run the registry:2 container. By default, it will store the layers, like the images, on the file system. If you want like a more production-grade deployment, you can just add a small config file that will define like a backend for the registry, like you could store into S3 or the Google Object Store, etc., etc. And then there is another trick or hack. By default, the Docker engine insists that you talk to the registry over TLS. This is because lots of people scream very loudly if they see insecure things, and they're like, oh, look, the Docker engine connects to registries but doesn't check certificates. That's huge security issues. We're like, okay, fine, we're going to require TLS when talking to the registry. So that way people will be happy. And we also require that the registry has a valid certificate, which kind of sucks if you just want to create your registry real quick and have things work out of the box. So there are a couple of ways to work around that. We could use Let's Encrypt to generate a certificate for the registry, or we could reconfigure the Docker engine to add the insecure registry flag, or, and that's the thing we're going to do, we could publish the registry on a node port, and that way it will be available on localhost on that node port. For instance, if the node port is the 34567, then we can connect to localhost port 34567, and that's our registry. And the Docker engine makes an exception to the TLS rule. If you connect to localhost, you don't need TLS, because even the NSA cannot snoop traffic that's going to localhost.